Hi there. In this video, I just wanted to give an overview of how I use my calculator for surveying. And this is the Texas Instruments TI-84 Plus. Let's look at doing some closures and how that works. So a closure is where you have some bearings and distances, and say if I have two known sides here and I want to work out this third side, then I can get my calculator to do that for me. So I'm going to go into my closure program, and it comes up with a menu at the start, just asking me if I want to start a new one or display the last one I did. So let's start a new one, and it's going to ask me to enter the bearings and distances that are known that I want to use. So let's start here, 36 degrees, 36 minutes, 30 seconds. 30.1 as the distance, and for this one 133.10, and this one's got feet and inches, so I can do 100 F plus 2 I, hit enter, and now I'm ready to show the results. I'm just going to hit a dot, enter, and it's drawn a little shape on the screen just to check that that's what I'm expecting. So the solid lines represent the known sides, and a dotted line is the unknown that we're trying to calculate. So it might be a bit hard to see, but our home point, where we start and end from, is got a solid square and hollow squares for the other ones, just to help you check your orientation and that sort of thing. So if I'm happy with that, hit enter, and it's giving me the closure result. So this line across here will be 265 degrees, 20 minutes, and 38, or rounded up to 39 seconds, with a distance of 40.351. And so the second bearing there is just flipped 180. So sometimes you might want it in the reverse direction. So it tells you there that the reverse. And if you happen to want more decimal places than the 3 by default, it'll just print out the full result there for you. So if I got a result that I wasn't expecting and I just want to check that I entered it right, I'm just going to hit enter again to run the app again. And this time I'm going to go to number 2 to redo the last, and it'll just print out what I entered, so I can just make sure that, yeah, I entered it 36, 36, 30, 30.1, 133, and this is showing me the value in meters, but that looks correct. So it'll just show the shape again and the results, so you can quickly redo your calculation just to double check that you entered it correctly. So now let's say we want to get this side over here. So we've got 3 known sides, and we want to work out what this one should be. So if I start a new one, I'm going to have to re-enter these 2 again and enter the third side, but I'll just show you another little shortcut that I can use to not have to re-enter the ones I've already put in. If I just hit this stat button up here, stat, and edit, then I get a little table come up on the screen. And so the left column shows me the 2 bearings that I entered previously, and sometimes the numbers round off, but if you scroll to highlight it, then you can it'll show it in full down the bottom here. So I've got 2 sides with 2, and column 2 has the 2 distances, and I want to enter a third one. So I'm just going to start down here and say 1 degree, 0 minutes, 15 seconds. Hit enter and go across and enter the distance, 42. Hit enter, and now I'm ready to just hit my program closure again. And if I go back to redo the last one, it's actually going to use the values that we just saw in that table. So I'm going to do that. It'll print them out on the screen again, just so you can double check that that's what you're expecting. Hit enter, and now I get it shown on the screen, and you'll notice here that hang on, something's looking wrong. We've got this this line going up instead of down, and that's because I entered the bearing as 1 degree when it should be actually going this way. It should be 181 degrees. So I don't want to proceed with that, so I'm just going to hit the on button to cancel and break out of that and go back to my table. And if I want to flip that in the right direction, I can either add 180 degrees to the bearing, which I could just type in here. I could just go to the end and add 180 like that. But I actually prefer to do it by just making the distance a negative. So I'm going to change to 42 and just put a negative sign in to make it negative 42, because I find that's a little bit easier and clearer for me to double check my inputs. And now we're ready to run that again. I can check, okay, yep, so now I've got a negative 42 here, enter, and now my shape's looking better. I've got 3 known sides and the 4th one going up this way. So this just helps check for sometimes mistakes if you might enter the bearing in the wrong direction. I find it's helped me get the right result sometimes when I might be missing it. And I guess it squishes the shape slightly just to fit it all on the screen, but generally this gives you the idea that things are looking roughly correct. So now I've got my results. So going on this side now is 314 degrees, 26 minutes, 25 seconds, 55.298. So I could just go ahead and write that in. I'll show you one other thing. There's sometimes you have this result and you actually want to rotate that by a certain amount to rotate it onto a different datum. Then you can hit the plus or minus at this point, and it'll say how much do you want to rotate your answer by. And so it remembers last time I did any rotations, it was 7 degrees, 40 minutes, 30. So I can just use that. If I hit the dot to use that, or I can actually enter a rotation that I'd like to use. So I'm just going to use that. And now it's giving me updated answer with the rotation added. So I can record that on my sheet if I need to. So that's done. Let's go on to these bottom two. So here we've got our 3 known sides, and this side we've got two unknowns. We just know the bearing that we want, but we don't know the distances of these two. So this is called a double missing distance, and I'll show you how we do that. So I can just, probably the quickest way is just to go back into my list again, and because I've already got the 3 known sides put in there, and I can just put in the 2 bearings that I want, 270 and 0, and I'm going to leave it empty in the second column because we don't know the distance. Run the program again, reuse my results, and so now it's just going to show the 2 bearings I've got there. That looks correct. So now when I run it again, it's going to show the 3 known sides, the dashed line across here, which is the closure, and then our double missing distance sides as well. So firstly, it'll give you the closure that way, and hit enter, and now I've got our missing distances as well. So 270 degrees, the distance would be 39.482, and this one 38.718. So that's done. Now if I'm actually entering, if I want to enter this during the program when I'm entering a new one, I'll just put these in pretty quickly. -42. So when I get to this point, I'm just going to put my bearing in as 270, and if this bearing here is exactly 90 degrees off, then that's all I need to do. I can just hit dot and finish there, and it'll automatically put in whatever the bearing is at 90 degrees off. If it's not 90 degree off, I can put 2 dots, and in this case it will ask me for an additional bearing, and I can put in, say, 30 degrees or something like that. And so now it's going to show me, here's a double missing distance going a slightly different shape like that. So hit enter. And now we have, yeah, the two missing distances. All right, so that's that part of the program. I think the next example is to show how I do arbitrary datum. So let's say in the field, I show up at a site and the existing plan gives me 3 known bearings and distances for these 3 points here. But for some reason I might choose to set up on an unknown point, and I don't know what bearing to start on. So what I need to do here is just measure the distances from my point A to B. So I start with I guess I'll just guess a bearing along here and start with that, and then use my instrument to measure to C, and then we can put that all into the calculator to give us the result. So I'm just going to go back into that same closure program, but this time I've got an option for arbitrary datum. So I hit enter on that, and it gives me just a little bit of a prompt. So you're at point A here, and it's saying measure A to B and A to C using any starting bearing. So I'm just going to say, what's that? I don't know, somewhere around, say, 330. If we start with that, and I got the distance from my instrument at 27.8, and then I measured from A to C, and we get, say, 53 degrees 17 minutes with a distance of 42.384. So what's going to do is do a closure and work out what the bearing and distance is across here. And based on my arbitrary datum, this is what the closure is. It's going to tell me on the calculator. So I'm going to hit enter. And now I enter the known traverse from B to C. So say 270, 02, 20. And because it needs to be from B to C, I'm going to just make this a negative distance. So it's going that way. So 47.892. And that's all I need to enter in this case. I'm just going to hit the dot to end. And so first it gives me the difference. So this is the difference in the bearings. So from my arbitrary datum to what the actual datum is 1 degree, 33 minutes and 5 seconds different. And the distance was actually very, very close. This is actually 0.0002 difference in distance. So very happy with that. And this gives me the corrected A to B. So this is if I rotate what I initially measured onto the right datum, then A to B would be 331.33, distance 27.8, the same distance as what I entered before. And now I corrected A to C. So from here it should be 54 degrees, 50 minutes, 5 seconds. All right, and yeah, if I want to just check my result, I can go back down to arbitrary datum app, and I can just hit the dot to re-enter what I entered last time, just to double check that what I put in was actually correct. So this was the arbitrary bearings that I started with. Check that the shape looks roughly correct. And then the next screen is enter the traverses from B to C. So if I didn't actually know what this one across here was, I can actually enter the multiple traverses. So I can put in this one, and it'll basically do the same thing. But I'm just going to reuse what I entered last time. and it'll just print the result out again. So instead of having to re-enter everything, I can just check that what I entered was correct if I'm getting some sort of result that I don't expect. So I'll show you one other thing. So I've got another app which I've found useful a few times, and this is similar to the Arbitrary Datum app, but it helps in finding points that might be buried in the ground. So let's say I get to the site and I know on the plan that I've got 3 points here, and I know roughly where they are, but perhaps I'm finding it very difficult to find one of them. So let's say this one up here, I've searched around and I just can't find this mark. Maybe it's buried under the grass somewhere. So what I can do is actually put my instrument pretty close by where I think it is, maybe within a few meters of the mark, and set up there. And then I just need to put in a few bits of information. So let's run this app. It's called Find Points. Going to run that. All right. So it gives you a little prompt. So you're at point A, and you have 2 known points B and C, and you want to find a point X. So let's say this one's X that I'm looking for, and I have 2 known. Yeah, this is my B and this is my C. So it's going to ask now, where is it X? Is it X between B and C, or is it on the end of it? So in this case, if we've got B, X, and C, then I'm going to use this mode. Otherwise, if we didn't have this bearing and distance on this side, then I could use the other mode, which is B to C to X, and so that just changes what inputs you're gonna enter into the calculator. It gives you both options, but let's go B, X, and C. So now enter the bearings and distances to the following points. So okay, so what B to X should be 50, 30, and 19.8, and X to C is 111.0952, 34.973. All right, so now I've set up my A, and I can actually just start on any arbitrary bearing here. So I'm just going to say normally I'd set up pretty close to where X is, because that helps you find it a lot more easily. But I'll just put in similar to what I put in last time, so that we can just check. So 330, and say it's 27.8, and A to C, that's 53.17, distance of 42.384. All right, so now it's going to tell me, based using the arbitrary datum that I was set up on, I'll find X at 1 degrees 35, 30, rounded up to 35 seconds, 37 meters away. And as I said, normally I like to set up pretty close, so that then it's only a couple of meters and you can, much easier to find. But in case I do want to actually, set up a real point at A, it gives me the actual back site from A to B, and also A to X rotated onto the actual datum in case I need to record that. So sometimes that's really useful to find things in the field when they're difficult to find.